Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to discuss numbers, inequalities, and absolute values. Let's do an example. Write the expression without using the absolute value symbol. Let's do part A. We have the absolute value of 2 minus 7. Let's work through this one. Solution. So we'll just start by subtracting. 2 minus 7 is negative 5. So we get the absolute value of negative 5. And recall that the absolute value of a number is the distance between that number and 0. So on the number line, the distance between 0 and negative 5 is just 5. The absolute value of negative 5 is going to be 5. Let's do another one. Part B, the absolute value of the square root of 3 minus 3. This one's going to be a little bit harder. Solution. So in order to do this problem, we have to know the actual definition of absolute value in terms of piecewise functions. So this is super important. The absolute value of x is equal to following function. It's x if x is greater than or equal to 0, and it's minus x if x is less than 0. This is extremely important in calculus. It comes up so much. So in this particular problem, we have to figure out which piece to use. So if you think about it, the square root of 3 is smaller than 3 because you're taking the square root of it. And if we subtract 3 from both sides, we get the square root of 3 minus 3 less than 0. That means we're going to use the second case. So the absolute value of the square root of 3 minus 3, well, our x in this problem is this whole piece here, square root of 3 minus 3. So we use the second condition because it's less than 0. So in this case, it'll be minus parentheses square root of 3 minus 3. Then you can distribute the minus 1. There's really an invisible 1 here. This ends up becoming negative root 3 plus 3. Certainly a little bit more challenging than the example with negative 5, but worth doing. Let's do another example. Part C, we want the absolute value of x minus 4 if x is greater than 4. Again, the definition of absolute value is the absolute value of x is a piecewise function given by the following. It's x if x is greater than or equal to 0, and it's minus x if x is less than 0. Super useful. In this particular case, we're told that x is greater than 4. So what we can do is basically subtract 4 from both sides, and that will give us x minus 4 is greater than 0. So basically that means that the absolute value of x minus 4 is equal to, well, using the formula, we're going to use the top piece. The absolute value of x is equal to x if x is greater than or equal to 0. In our particular case, the entire piece here, x minus 4, is like our x. This is just equal to x minus 4. And that would be the answer. Let's do another one. Part D, we want the absolute value of x minus 4 if x is less than 4. Again, very similar to the previous example, but worth doing just to get the point across because it's so important. Subtract 4 from both sides here, we're going to get x minus 4 less than 0. And then so the absolute value of x minus 4 in this case, well, using the definition of absolute value, x minus 4 is less than 0, so we use the bottom piece of the function. So instead of negative x, it's going to be negative x minus 4. And then we can distribute the minus sign here. It'll be negative x plus 4. Really nice. Okay, let's do something a little bit different. Solve each inequality. Part A, we have the absolute value of x minus 2 less than 1. Let's work through this one. Solution. So this is a really useful inequality to know how to solve because it comes up a lot in calculus. So if you have the absolute value of x less than a, where a here is a positive number, let's think about this. This is saying that the distance between x and 0 is smaller than a. That means that x must be a number between a and negative a. And that's how we express it algebraically. We write negative a less than x less than a. Whenever you have the absolute value of x less than a, you basically drop the absolute value and you put an a on the right-hand side and a minus a on the left-hand side. In this particular example, we have the same thing. Our a is 1. and we have a less than. So we can drop the absolute value right away. And we have x minus 2 less than 1, and then greater than negative 1. To finish solving this, we just add 2 to all three sides. Plus 2, plus 2, plus 2. These cancel, so we get 1 less than x less than 3. In interval notation, we would write this as parentheses 1, comma 3. And that would be the solution in this particular problem. If you wanted to see a graph of your solution, you could draw the number line like this. Here's the number 1, here's the number 3, and it's basically all of the numbers between 1 and 3, so it's going to look like this shaded yellow region here. Let's do another example. Part B, the absolute value of x greater than or equal to 4. So let's think about this for a minute. If we have a and it's a positive number, and we have the absolute value of x greater than or equal to a. What does this mean intuitively? It means that the distance between x and 0 is greater than or equal to a. That means that x is bigger than a, or it's smaller than negative a. Super useful, super important. So in this particular problem, our a has the value of 4. So again, the distance between x and 0 is bigger than or equal to 4. That means that x is greater than or equal to 4, or it's less than or equal to negative 4. Because its distance from 0 is greater than 4. And now what we can do is we can draw a picture. So here's 4, here's negative 4, and we want x greater than or equal to 4. So it's going to be over here with a bracket. We use a bracket, by the way, because we have an equal to sign. In the previous example, we used parentheses because we had a greater than sign. Whenever you have equality, you throw the brackets in. And then less than or equal to negative 4 would be over here like this. So you can see this matches what we're talking about with distance. X is a number whose distance from 0 is greater than or equal to 4. So the final answer would be negative infinity to negative 4 with the bracket because we're including the negative 4. Union, and then 4 to infinity. And that would be the answer. Just to really make the point, whenever you have like less thans or greater thans, you're going to use parentheses. And whenever you have less than or equal tos or greater than or equal tos, you're going to use brackets. Really nice. Hopefully after watching this video, you feel like your math has gotten a little bit better. If you enjoyed this video, make sure to check out Chegg for more videos. Good luck.